Hello everyone, I'm Yoshihiro Banchi from Waseda University. Now I'd like to talk about effect of binocular parallax in 360-degree VR images on viewing behavior. Recently, various HMD like standalone HMD are on sale. In addition, VR dedicated distribution platform has been formed. In VR, it is very characteristic that there are pictures in all 360 degrees. And it is necessary to study about user experience as optimum expression method, safety, and comfort based on them. In addition to that, we are studying focused on how to view 360 images. This video is an example of a person viewing a 360 image. Of course, the viewing behavior is quite different from the flat display. In our previous study, some results were obtained with regard to body movement and contents at viewing 360 pictures. It is shown that the head movement was horizontal and vertical independent and occurred, and it is influenced by the number and arrangement of objects included in the contents. It is also found that it took a certain period of time to prepare for observation with physical behavior. As our previous study, some results were obtained regarding eye movement and contents during 360 videos viewing. There are contents such as a roller coaster with much camera movement and a landscape with less camera movement as features. Overlay gaze heat maps. There are a tendency to observe as if there was front. It is also found that the chair swiveling affected the user experience. From these results, there was a tendency to pay attention to front regardless of contents. On the other hand, the difference between stereoscopic and 2D is not clear. In this research, we aim to clarify how information front and stereoscopic affect 360-degree images observation. Therefore, 4 stimuli with different disparity distribution were prepared as conditions. The conditions were 3D, 2D, front-back 3D, left-right 3D. Next, the stimulation will be described in detail. The stimulus image of this experiment is the front of the center of the conference room. This stimulus was created using Insta360 Pro. It is capable of shooting in 360-degree and stereoscopic images, and it was set as a 3D condition. And in this experiment, the front was taken as a whiteboard. In the 2D condition, the image for the left eye was displayed on the both eyes so that there was no parallax. In the front-back 3D condition, here FP3D, it divided 90 degrees horizontally on the whiteboard, set the 90 degrees of the front and back to 3D and 90 degrees of left and right to 2D. On the other hand, under the left-right 3D condition, here LR3D, the front and back 90 degrees were set to 2D, and the left and right 90 degrees were set to 3D. The measurement indexes acquired acquired eye tracking data and head tracking data as objective indexes. Therefore, SMI mobile eye tracking HMD based on gear VR, which can measure gaze, was used. As subjective indexes, it was conducted the 7-rate rating scale and oral interview. The question items were made from the previous research on the evaluation of the 3D image on image quality, reality, naturalness, depth, and viewing experience. About the procedure, first, the purpose of the experiment was explained to participants in advance, and their consent was gained. The stimulus was freely observed for 60 seconds after calibration to control the eye movement. After each observation finished, participants answered to questionnaire. The order of conditions was randomized. This picture is about the layout of this experiment. Participants wore HMD and ear muff, considering the influence of sound. The experiment participants were 20 university students. In HMD, gaze points are considered two types. The one is on the HMD screen, which means the gaze point at the field of view. In other words, it can see how you moved your eyes in HMD. And the other is in the spherical VR space, which means the gaze point in all the spheres. In other words, it can see which point you are focusing on in the 360 image. This figure is an example of the VR spherical gaze. In these examples, it can see that the gaze was concentrated on the front side and much moving horizontally. In this analysis, the VR spherical gaze is important, so we have focused on it. Next is the result of objective indexes. This graph is the average of the gaze time of each participant stayed in each direction of 19 degrees. From this graph, some features were seen under the 3D condition, but no large bias was observed in the distribution of the gaze, and no large difference was observed between the stimuli. Therefore, we focused on the analysis of time series characteristics. This is the average of the gaze time in each direction from 0 to 20 seconds. From this graph, differences were seen between FB 3D condition and LR 3D condition. Especially in front and left, it seemed that the gaze time differed depending on conditions. Due to the Watson-Wheeler test of circular statistics, it was significantly recognized that it has different distribution except between 2D and 3D conditions. From this fact, it's found that the gaze was attracted by binocular parallax immediately after the starting of the image displayed. Next, this is average of the gaze time in each direction from 20 to 40 seconds. From this graph, it seemed that the gaze was stayed in the direction not being viewed in 0 to 20 seconds. Now this is 0 to 20 seconds, and this is 20 to 40 seconds. It is quite different of the gaze time from upper to lower and lower to higher. From this result, it is found that after a while from the start of the image displayed, the gaze moved in a direction other than the direction induced by the influence of binocular parallax immediately after the starting. This graph is the average of the gaze time from 40 to 60 seconds. From this graph, it seems that the difference in distribution became small compared with the gaze distribution from 0 to 20 seconds and 20 to 40 seconds. Due to the Watson-Wheeler test of circular statistics, it was significantly recognized that it had different distributions among all the conditions. Although significant differences were recognized, but it is thought that the similar gaze distribution appeared due to the information of front, while being influenced by binocular parallax because the distribution differences became small. Next is a result of the depth of the subjective index. The vertical axis of the graph is about the score, and the horizontal axis is about the stimulus. On the analysis of variance and multiple comparisons, it was found to be significant differences. Especially, the 2D condition was found to be significantly lower than the other conditions. From this fact, it is found that the subjective depth feeling was increased by adding parallax to a part of the area, even if it was not a whole stereoscopic view. In this research, we have examined the effect of binocular parallax and front in 360-degree VR images from viewing behavior. From the result, the following findings are obtained. As the influence of distribution of binocular parallax, it turned out that it changes with the lapse of time. The gaze is attracted by parallax soon after the start of viewing. After a while from the start, the gaze moves in the direction not attracted. But particularly subjective depth also increases. In addition, it is found that this tendency occurs even with images with parallax in part. After seeing the whole, the influence of front became increasing. In future tasks, the simple study is the examination in videos. Furthermore, it investigates what happens when parallax is dynamically added. For example, whether it is perceived as a point of interest when adding to a moving object such as a person. From these facts, it is suggested that effective parallax can be added in 360 images. In creating content, the point of interest where viewers are interested may be different. At that time, there is a possibility that using parallax effectively, you can guide the gaze to the point where the creator wants the viewer interested in. Also, although gaze concentrates on the front so far, it is suggested that it could be making conscious of front more strongly or conscious of besides the front. Thank you for your kind attention.